Hey guys, today we're going to be talking about mid-segments of a triangle. Okay? And there's a definition that you need to know for mid-segments of triangles, and that definition is, go ahead and write this down. Write down, is a segment that joins the midpoints the segment that joins the midpoints of two sides of a triangle. Okay, it's a segment that joins the midpoints of two sides of a triangle, and each triangle has three mid-segments. Okay, now that can be kind of wordy, but let's go ahead and draw a picture to kind of illustrate what I'm talking about here. Okay, so let's say you had this triangle QPR. Now it says that a midsegment is a segment that joins the midpoints of two sides of the triangle. So first we need to identify the midsegments on each side of our triangle. Now QR, this guy, its midsegment would just be right in the middle of that segment. Just like that, PR would have a midsegment right in the middle, and PQ would have a midsegment right in the middle. Now, the midsegment of a triangle is when you join those midsegments with another segment, so you could draw a line in between them. Okay, and those lines form a new triangle. So you can rename those, and we typically rename them X, Y, and Z. And then we can talk about all the midsegments of that triangle. So our midsegments would be the segments XY, YZ, and XZ. Okay, so those are our three midsegments of that triangle. If we wanted to name those 3 points as a triangle, we could say the midsegment triangle is named triangle XYZ. Okay, so this is what I'm talking about so far, and they're going to ask you to do some questions that are very similar to this information. Okay, so make sure you have that written down, you have that picture drawn. All right, let's quickly take a look at this example here. And it's kind of wordy, but let's take it piece by piece and really kind of break it down a little bit. Okay, so it says the vertices of triangle XYZ are these 3 vertices. Okay, so let's go ahead and graph those 3 vertices over here in our coordinate grid. Okay, so the first one we have -1, 8. That would be located right here, and that was point X. Okay, so let's go ahead and label it point X. Our second one was 9, 2, so let's go ahead and go to 9, 2. So we go over here 9 and over 2 and up 2, and that's our point Y. And our point Z was 3, -4, so go over 3 down 4, and that's our Z. All right, so let's go ahead and connect our points here between our 3 points. And there you have it. There's our triangle. Okay? All right, so now we need to analyze the second part of what the problem says. And it says that M and N are the midpoints of XZ and YZ. Okay, so we need to go ahead and find the midpoints of XZ, or this line, and the midpoint of YZ, or the midpoint of this line. Okay, and what is our midpoint formula? Well, if you remember back in the day when we learned about mid formula, you'll remember that it is x1 plus x2 divided by 2, and y1 plus y2 over 2. And your answer should end up being an ordered pair. Okay, so that's your midpoint formula. So let's go ahead and figure out the midpoint of xz and yz. Alright, so let's go ahead and start calculating the midpoint for these guys. So let's start with xz. And we want to plug the ordered pairs of xz into our midpoint formula. Remember, x is -1, 8, and z is 3, -4. So we're going to go ahead and plug that into our formula. So our x1 would be -1, our x2 would be 3, and we would divide that by 2. And our y1 would be 8, and our y2 would be -4, and we're dividing that by 2. So if we go ahead and calculate that, -1 plus 3 is 4, and 4 divided by 2 is 2, so our first number in the ordered pair is 2. And then 8 plus -4 is 4, and divide that by 2, and you also get 2. Okay, I need to correct something real quick. This part right here, -1 plus 3 is 2, and 2 divided by 2 is 1. So this should be a 1, my mistake. Okay, so the midpoint of xz would be 1, 2. Now let's find the midpoint of yz. Okay, yz, your x1 plus x2 should be 9 plus 3 divided by 2. And then your y2 plus y1 should be 2 plus -4. And we're going to divide all that by 2. Okay, so let's go ahead and reduce. 9 plus 3 is 12. 12 divided by 2 is 6. And 2 plus -4 is -2. And -2 divided by 2 would give us -1. Okay, so there's our midpoints between each of those 2 points, or 2 segments. And basically what we want to show is that MN is perpendicular to XY. But I'm not going to have you do that right now. We've done plenty of work on this problem. So let's go ahead and call that one good. Alright, so what we're really here for today is to learn about the triangle midsegment theorem. Okay, and the midsegment of a triangle is parallel to the side of a triangle, and its length is half the length of that side. So for instance, in a triangle, you will have a line that's parallel to another one, and the short one is going to be 1/2 the length of the big one. Okay, so that's what I want you to take from that. So if you have 2 lines that are parallel, one is half the length of the other. Okay, so let's try an example here. And the example says find each measure, and we want to find what BD is. Okay, so we want to find what this segment right here is. Well, we know that BD is parallel to AE. So we know that, if you write this down, BD is going to equal 1/2 of AE. Okay? And we know that AE is 17, so we can plug in 1/2 times 17, and that would give us BD equaling 8.5. Or you could have just taken 17 divided by 2, and that would have given us our solution. Okay, so make sure you have all these notes here, and be ready for a few more examples on the next page. All right. Before we get started with some more examples, I got a quick joke for you. What do you call a cow with a twitch? Think about it. Think about it. Beef jerky. You like it. Okay, so we want to find each measure in the triangle here that it's provided us. And the first one we want to find is JL. Okay, so we want to find this segment right here. Well, let's go ahead and find a segment that's parallel to it. Well, we know that PN looks to be parallel to it, and we know that PN should equal 1/2 of JL. Since it's the small one, JL should be twice as big. Well, since PN is 36, we can just take 36 times 2 and get 72 for JL. Okay, so simple as that. Let's try PM this time. Okay, so we're wanting to find the segment that is, let's put it in blue. We're trying to find PM. Okay, so let's go ahead and find PM. Well, let's look for one that's parallel to it. So we have PM, and the one parallel to it would be LK. So we know that PM should be half of LK, and since we know that LK is 97, we can divide that by 2, and we can get 48.5. Okay, so there's PM. You're just wanting to look for the ones that are parallel to the line you're given. Okay, let's try the last one. We want to find MLK. Okay, so let's try another color here. That way we can keep it easy. So we want to find the angle MLK. This like little cyan color is what we're trying to find. Okay, well, we've learned in the past that these types of angles are congruent. So MLK, we see that JMP is 102 degrees. Well, we know this angle and this angle are congruent, so we can say that MLK is also 102 degrees. Okay? All right, let's try a few more here. All right, let's skip number 3. Let's try number 3. Okay, we want to use the diagram for items 1 to 3, and we want to find each measure. So ED is this segment right here, and we want to find it. So since we have ED being parallel to BC, and we know that BC ends up being 20, we can say that ED would be half of that. So what's 20 divided by 2? Well, that is 10. Okay, let's try AB. Well, we know AB is parallel. AB is parallel to FD. So we know that AB is twice the length of FD. And since FD is 7, we want to multiply that by 2 to get our length for AB. Okay, let's try our last one. We want to find BFE, that angle. Okay, so we want to find this angle right up here. Okay, and we are given the fact that FCD is 44 degrees as well. So since these are similar triangles, we know that both of them are 44 degrees. Let's try 2 more and then we will be done. All right, so these last couple we'll take a close look at, and we know that these 2 lines have a relationship. They're parallel to each other. Well, what do we know about this one? We know that it takes 2 of these to equal one of the longer pieces. So we know that we can set up an equation. We can say 3n plus 12 equals, so that's this segment, and we know that it takes 2 times this length to equal this guy. So we can say that 2 times n plus 14 equals the big segment. Okay, so let's go ahead and solve this. Let me zoom in for us. So we have 3n plus 12. Let's distribute. Gives us 2n plus 28. And then we can subtract 2n on both sides, and gives us n plus 12 equals 28. And then, of course, you can subtract 12 on both sides and get n equals 16. And that would be our final solution for what the value of n is. Okay? All right, last one. And our goal in this problem is to find the perimeter of xyz. So we want to find the length around this triangle. Okay, so we're given the initial value of yz is 3, so we are done with that one. But we need to find the other. Let's start with xz. Okay, so let's find the length of this. Well, we can see that these two are parallel, and since they are the same length, we can go ahead and determine that xz is a length of 4. Since vy is 4, xz is also 4. Then we need to find what length xy is. Okay, well, we can see that uw is parallel to it, and it has a length of 9. So if xy is 1/2 of 9, we know that that length would be 4.5. Okay, so let's add these up. 3 plus 4 is 7, and 7 plus 4.5 would be 11.5. So that would be our perimeter of xyz, this entire triangle length. All right, see ya.